Good evening, ladies and gentlemen, and welcome to the first ever virtual BLSI Business and Economics series. It's my great pleasure to welcome Dr. Nazir Salari from Bath Spa University tonight to give us a lecture on practical applications of implementing data systems in business. Nazir actually gained his BSc in Iran, Tehran, some time ago. He then had his master's and his PhD in the University of Birmingham. And now he's at Bath Spa as the leader in marketing and marketing management. And today he's going to talk to us about data systems and how to integrate them. I know you won't be able to clap at this point, and I think we reserve clapping later on to the Q&A session, but it's my great pleasure to welcome Nazir Salari.
Right. Thank you very much for the introduction. Yeah, it's a pleasure to give this presentation today. Yeah, my name is Nazir Salari, and I'm a senior lecturer in marketing at Bath Spa University. So my background actually is mainly on quantitative marketing, and over the past 2 years, I have actually shifted towards data science in marketing, which I'm gonna talk about today. So I'm gonna I think I'm gonna stop my own video and then start sharing the screen that I have. So that's, I believe you should all be able to see this one. So anyway, so these are my email addresses, my university as well as my personal email, just in case if people have got questions at the end. So this is going to be the outline of today's session. It's going to take about 45 minutes or so. I hope I can, keep everybody engaged until the end of the session. And obviously, I'm happy to take answers for for any. I'm happy to take the questions for from the audience. So I'm going to talk about what is it. So what is the data science and what skills are required. Perhaps people have heard the word big data. So what is it? Is it a kind of buzzword, or what is the exact definition of it? And what kind of technologies do we have in the industry and so on, and then what makes data science different than data analysis is the concept of machine learning. And again, we all have heard on the news, artificial intelligence is going to take over, the future is going to be the computers, dominating humans. Yeah, it hasn't happened, yet. But I mean, machine learning, which is the ability of the computers to learn and think like humans, is something that separates data science from data analysis. I cannot cover everything, in data science because it's such a vast topic, but, I do my best in order to demonstrate some practical examples, such as deep learning, what is deep learning, and NLP. And finally, if someone is interested, in any data science projects, in the future, or for any audience who is watching this video in the future, I'm going to summarize at the end with this. So data science, well, I said that my background is in marketing. So how come, I am familiar with data science, and I have actually worked in data science projects. It is the interdisciplinary field, yeah? So it's about using scientific methods to extract knowledge from structured and unstructured data. So what is unstructured data means, I'm going to show you an example. But businesses are not always lucky enough to have this structured data. And what we mean by structured data is that, for example, if we have a spreadsheet file, an Excel file, this is a kind of, structured data, because the data are presented nicely as columns. It has a heading. It's there. It's available for us to do any kind of analysis. But we have heard that there are tons of data on internet and generated like every second, and there is a value behind it. That's true, but a lot of them are unstructured. So we need to actually do something. The first step is to make them structured, and then, as you can see in the third point, we need to have sets of skills in mathematics, statistics, artificial intelligence, machine learning, databases, which means that data might be stored in different databases, and we need to actually extract them from different databases, and in order to join them, and finally do the optimization, which I will clarify what it means. And so yeah, I mean, anybody who's got the skills in these areas could be a data scientist. So it's not just only restricted to somebody who has got like computer science background, and in terms of mathematics and statistics, mathematics that we need would be the kind that we learn in the secondary school, linear algebra, as well as the concept of matrices, and statistics. Anybody who has taken any statistics during the PhD and so on, would be able to apply the concepts and techniques in data science. And depending on the field that you're working, we also need to have a good understanding of the problem formulation in order to provide the effective solution. So if it is about data science in marketing, then obviously you need to have the marketing knowledge, or if data science is applied, for example, in medical science, then you need to have the knowledge of the relevant field that you're working with. So what is this big data then? Yeah. Well, we have heard this term quite a lot. Perhaps, I don't know, some people are like this guy, who's heard from some people that, like, consultants say that, there are tons of data created every day. It's coming everywhere, like a cloud. I don't know, in the past, our company didn't use it. So if we accept big data in our servers, then, we will be saved from the bankruptcy. Then let's pay these consultants, And to be honest, I should tell you that it's a very nice way to add zeros in front of the juicy contracts, this big data. Because technically speaking, not every data is a big data. Yeah. So, for example, I might have a data set of, let's say, there was a data set I downloaded a few days ago. The data of 7 million companies, in a spreadsheet. Is that big data? I would say that it's a very large data set, and especially, a size of 7 million. If we can actually, find interesting, patterns in the data, that would be great. But I wouldn't call it big data yet. One of the reasons is that I could save it in my laptop. Yeah. There is an official definition of how much volume, of data we are talking about in order to call it big data. But we are talking about, I don't know, hexabytes of data, like something very, very a large volume of data that, we can't even store it in our laptop. And if we write a code and we want to implement it, it would be very slow. Then the data actually should be stored, in variety of computers. Yeah. Because, if the data is only stored in one machine, and what if that machine breaks, then, we can't do anything about it. So part of it, yeah, is about volume. The other thing is about the variety. So the variety of data. So if the data is not just only of one type, and we got data of, of variety, then that's another characteristics of the big data. The other thing is actually the veracity and velocity. So veracity actually refers to since actually we have collected big data, it's about the degree of reliability that the data has to offer. So it's about finding a way to get rid of unnecessary and irrelevant data. So not every data is going to be suitable for our business needs. And finally, velocity. So that means that, when you have the data, you've got two approaches. One is that sometimes, we can just wait until the end of the month, to analyze the data that we have or build the machine learning models and so on. Sometimes we have to actually process the data on the go. So as soon as we receive them, we have to actually, process the data. Yeah, it's called, like, the technical term is stream processing. For example, for a bank, if they actually want to stop a suspicious transaction, a fraudulent transaction, they can't actually wait until the end of the month, to actually detect the fraud. Once the transaction happened, then the bank must stop it, and this is something that we see that it has improved. In the bank services, that they send you a text and say that this transaction, we think that this is suspicious. If you can confirm it, then say yes. If not, say no, and so on. Yeah. So this is what we mean by big data. Okay. Again, we don't have to have big data in order to build machine learning models, but when we talk about big data, then technically speaking, this is what we're talking about. In terms of the technologies that are used in the industry for the big data, here we go. So this is these are the technologies used in the industry. So as you can tell, it is impossible for somebody who says that I know all of them, obviously. So every technology, every software that you see here is actually related to, different aspects of big data. I don't know, SPSS, is something that PhD student, does at MATLAB. Microsoft Azure, again, it's popular, Oracle, and so on. One of the most popular ones I can tell you is this one is called Apache Spark. If we are working with big data, since the data actually is distributed, between different computers, it would be difficult actually to work with them. Apache Spark is a technology that provides an illusion to the person who's working with data that person is working with one machine. It's an illusion that it provides. Again, it's beyond the scope of this presentation to tell you what's exactly happening, but just to tell you that when we talk about big data, I mean, we can talk any of these technologies that is presented in this design. And actually, that's for 2016 anyway. Yeah. So the life cycle of data scientists. So this is what I grabbed from the University of Berkeley. I mean, data science has become very popular. A lot of universities, especially in America, they have actually put this in their educational program, and we are seeing, more and more graduates in this area. The market has become more competitive, but on the other side, the number of jobs for data science is also increasing. I mean, apart from the fact that anyway we are in the exceptional situation now due to the coronavirus. So Anything that relates to capturing the data, processing the data, maintaining the data, analyzing and communicating data. This is a kind of cycle of data science. And of course, the first thing, as I mentioned, is is to collect the data. And maybe some data scientists, they spend the vast amount of their time just doing the data cleansing. Yeah. So let me show you an example. Okay. This one. Okay. So this is the BBC website. Yeah. For example, it's a very simple example anyway. Yeah. What if I go to the bbc.co.uk/news? So we see the news right now. So these are the URLs, the links. Yeah. Depends on the business objective. So some businesses are interested in analyzing the text or text mining. Yeah. Which again, it will lead to the NLP topic that I'm going to talk about briefly. Yeah. One of the things is that, okay, so I want to actually grab all the headlines here. Okay. And then, for example, like this one, there is a text here. Okay. Am I interested in the image? Yes, no. Again, it depends on your objectives, of what you're going to do with the data. But let's say that, okay, well, I'm just interested in the text. Yeah. Okay, so I actually want to grab the BBC data on the news page, everything that is in the first page, grab the URLs and the text of the URL and the text of the news. Okay, so I'm going to show you how it works. For example, okay, so this is what we see. So let me actually get rid of that file. Okay.
Nazir, it's Andreas here. We can't actually see the website. We still are on the data science lifecycle slide.
Aha, okay. That's weird. You can't see the BBC website, no?
No, we're still on your slideshow.
What about now?
Now we can see it.
Okay, yeah, I'm sorry about that. Okay, so yeah, that's what I was saying. So this is the BBC website here. So what I was saying was that yeah, so if we are interested to grab the text of the of the news, yeah. So we see the URLs here, and if we click on this, then we see the text. And yeah, we can say that I don't want the images, but maybe you're interested in the image. It depends, yeah, on your objectives and so on. Okay, so can we actually automate the data collection? Because in reality, I'm not gonna click on every single link and then just copy and paste it. It's not going to work like that. Okay. One of the things that can happen in automating the data collection is using web scraping. Yeah. So I already have written a very simple code which I'm going to show you now. So you see there's nothing here. So yeah, but I assume that you see this terminal. So I'm gonna just, don't worry about this thing that I'm writing. Okay, I'm gonna call it like today news and then .csv. Okay, so I'm gonna store all this information in a CSV file right now. Let's see if it works. Yes, it's working. Here we go. Job done. Okay, in a few seconds. So I have actually grabbed all information. Let's open it. Here we go. So this is, what I have just gathered. So this is a structured data. So I have actually created a data set. So these are the URLs that grabbed from the BBC News. That's the headlines, and this is the body of the text. Yeah, I can copy and paste it in a Word for you to see exactly how it works. So here we go. That's the text of one of them. Okay, just the text. So easy. I have actually grabbed 43 URLs, so I can even schedule it to actually grab more data. So I can schedule it, to actually grab data. Actually grab data like 3 times a day, 4 times a day, it depends. Yeah, I can even grab data like this from other news websites. So I can even just ask my Spider to grab data or every news that is related to coronavirus only, or grab news that is related to football, whatever. Yeah, I can even apply more filters if I want. So data gathering, yeah, can happen like this. The other thing that I can do, I don't know, let me actually change to the website again. So for example, another thing, I can go to the Rightmove website right now, the other thing, and then, grab data about house prices. So I don't know, so that's the sold house prices. I'll go to Bath, list view, and then what I can do is that I can create another spreadsheet that I just showed you to grab all the information, just the postcode. I'm not interested in the address. Grab this one. So whether it's how many bedrooms we've got, whether it's a house or flat, traced, detached, semi-detached, whatever, the historical prices, and so on. Create a nice spreadsheet, yeah. And there are actually 40 pages. So automatically click next and then grab other information and so on. Yeah, nobody, copy and paste, by hand like this. Yeah, and once we have the data, then we can actually start building the machine learning models that we have. So get back to my presentation. So this is, one of the things, this is the first step, yeah, before we want to do anything with the data. But the point is that we need to know what we're doing. Yeah, so what's the point of collecting these data? When we are actually working in the data science, then there are some programming languages that are used in the industry. And you may wonder that what are those languages? It could be anything, depends on the company. But as you can see, Python is the language which is sitting on the top of the table, followed by SQL. SQL is an old language. Anybody who study a bit of programming, must know this. It stands for a structured query language. It's for making queries from databases. Yeah. It's not really hard, to be honest. If somebody just spend a few days on it, they learn it easily. R is also another one. Personally, I don't know R, but yeah, either R or Python, if you know one of them, should be good. Other languages you also see here, even VBA. So VBA is the one that, for example, if we use the macros on the Excel, yeah, it's actually the VBA language. And I remember, I think it was last year that I did one training session for one engineering company in Bath, that they wanted to have an advanced training course on Excel, and they wanted to learn the macros, which actually made me to learn the VBA, before running the session for them. Okay. Well, anyway, so this is what's happening in the industry in terms of the programming languages. So once we have the data available in any way, yeah, if you're lucky enough that the data is already available for us, nice, clean, everything is fine, then fantastic. If we have A company actually should feel very lucky that if we have if they have, you know, like a bigger spreadsheet that includes every single data that they want, you know, in one single file. Fantastic. Yeah. So machine learning means using algorithms, yeah, you know, that using statistics to find patterns. What we mean by patterns, you know, I would explain a massive amount of data. Yeah. So data could be anything. It could be images, it could be text, it could be numbers, etc. But for computers, images, text, yeah, everything, these are actually numbers. So when the computer analyzes an image, it's actually the pixels of the image. Yeah, a black and white, a very simple black and white image is 28 by 28 pixels. Okay, even text is actually numbers, and in fact, everything in data science is presented as a matrix or as an array. Yeah, so if you do remember at the beginning of my presentation, I said that, you know, in terms of mathematics, one of the things that we need to learn and apply in data science is the matrix calculations, you know, dot products, you know, these things that we all learned in our secondary school. Perhaps, you know, we may have forgotten, you know, but I mean, these are the concept behind it, you know. Is based on the matrices and the presentation of data in the matrix. We use machine learning to predict something. That makes it different than data analysis. In data analysis, you describe the data, you create charts and bar charts, graphs, and so on. In machine learning, we learn the pattern on the data in order to predict the future. Yeah, it could be predicting the house prices. So the example I showed you, that if you have a data set, if you grab the data, or if you find a data set about you know, the housing market, then you know, you can build a model in order to predict the house prices and so on. But when we want to teach the computer to make the prediction for us, or build a machine learning model, it can actually happen in two forms. One is called supervised learning, which means that the computer learns under your supervision. The simplest example I can give you is that it's like a dog which is learning under your supervision. Yeah. And the other thing is, the other form is called unsupervised learning, which means that we allow computer to learn in its own way. Yeah, which I'll clarify further. But anyway, this is the process of supervised learning. We always have a target for us, and target would be, as I said, what's going to be the house price, you know, in a certain postcode, you know, in Bath, you know, given the data that we have. So we supply the data. Yeah. And then, you know, the computer actually learns the pattern, you know, so this is what we mean by function. And then, you know, it gives us, you know, the target. And then we can actually test that how accurate, you know, our model was, yeah, based on the training that we provided to the machine. Yeah. Very simple example. Everybody who is, you know, using machine learning for image classification, so perhaps they are working with, you know, similar data set. For us, as the humans, when we see these images, very quickly we identify that there are only two categories of data here. So the image either belongs to a cat or dog. Yeah, so there's cat, dog, cat, and so on. Yeah, so how do we know? How do we know as humans that, you know, this is a cat, this is a dog? Yeah, we know it because we have been trained, you know, since our childhood. Our parents told us that, you know, this is a cat, this is a dog, and so on. And we have always seen, you know, in the books, on TV, everywhere, yeah, that, you know, this should be a cat, this should be a dog. Yeah. So the same thing we should also do for the computers. We should define it. So that means supervised learning. Yeah, so the computer should learn under our supervision. We should define the labels. Yeah, and again, the technicality on how it should be done in terms of coding and so on is again beyond the scope of this presentation. But we should define for the computers the labels. Yeah. So we supply the images. So there are actually, so that's 6, 1, 2, 3, there are 30 images here. In a real machine learning model anyway, the sample size should be much larger. So we don't train the computer just based on 30 images, just based on a much larger sample size. Yeah. So we define the labels for the computer learns, and then we supply the new data. Yeah, so we tell the computer that now you have learned that what they are. Yeah, I'm gonna give you the new images, and this time I'm not gonna tell you what they are. You do the categorization by yourself. Yeah, and then we will see that how accurate the computer has done it for us. Yeah, and then we can come back and improve the model. Yeah, in order to make it better and better. So this is the process of the supervised machine learning model. So we've got, we define the labels. So these are cats. Doesn't matter, in what shape. So we actually present different shapes of the cat. Yeah. So we don't present only like this cat. So this is cat. This looks very angry. Yeah. This is also another cat. This is also another cat, and so on. So the computer sees that, the cat, no matter how whether the cat is smiling or in what shape is presented. Yeah, it learns all of it. Yeah, and then it does the classification of the images. So image classification is something that everybody who's working in the in the machine learning is it has practice actually with this. In reality, we can see that is the image detection or object detection is used in the for example in fighting the crimes. For example, if we've got the data sets of the images of the criminals, yeah, then we can easily use the supervised machine learning model or the artificial intelligence in order to capture the criminals, for example, yeah, and so on. During anyone's PhD or even at at anyone's university education, anybody who builds a regression model has kind of done the supervised machine learning model, because the regression line actually is developed as a result of the data that you provide to the computer, and you ask the computer to find the best line that can represents the data. Yeah. So a lot of people might have actually developed a machine learning model in their education, or anything that's about classification. Yeah. In marketing would be like dividing the consumers based on like loyal and non-loyal consumers, or even we can have actually multi classification scenario here. So the process works in this way. So we have the data. So if we have a large data set, yeah, get this one, then we can split it into two sets of training the data and test the data. So again, it's up to the researcher. So we can say that like I divide my sample into like 70% and 30%. So if I have like 1 million images of cats and dogs, then 70% of that is for training. So once the computer learn, then I test the computer actually to by supplying the test data, or we can sometimes call it unseen data, and see how good the computer has classified the images. Yeah, and this is the accuracy. Yeah, so normally if you come up with a model that has got like more than 90% accuracy, that's fantastic. Yeah, and again depends on how much accuracy you want or how much accuracy you can achieve. With images, I can tell you that it has actually developed really well. So there are many models and examples that classify images really, really well. You can see that in your own iPhones, that when you create the album, it does the classification of the images. Yeah. And sometimes, if you have the photos of the family members in your iPhone, sometimes it's asking you to type the name of that person. This is actually labeling. Yeah, so this is actually you're helping iPhone, you're helping Apple to improve its machine learning algorithms. So this is about supervised learning. Unsupervised learning means that you are presenting this data to the computer, but you don't tell the computer that what is what. Yeah, you don't say that which one is cat, which one is dog. The computer would be able to identify two classes anyway. Yeah, so if you supply to this, so it tells you that, yeah, there are two classes. I could identify two classes based on these images, but I don't know what they are. Yeah, because we haven't told the computer. So in practice, supervised machine learning works better than unsupervised, but both of them anyway. I've seen that they're being used in the industry. Okay, so that's the whole machine learning process, regardless of what kind of data that we have. Yeah, so whether it's an image, whether it's a text, and so on. So we need to pre-process the data. That's the first thing. We need to do the data cleaning, or sometimes converting our data. Maybe the data should be turned into standardized score and so on. Again, I'm not going into details again beyond the scope, but this is the first step. Once the data is ready, and as I said, we split the data for training and testing. Again, 70%, 30%, or 60-40, or 80-20. Yeah, so people have got different approaches. We train the data, so learning the patterns of data. We apply the learning to the test data or unseen data, and we measure the accuracy. Yeah. And do we need to improve it or not? Yeah, so it depends on the accuracy score that we get. So this is the whole machine learning process. And lots of examples: predicting the house prices, the likelihood of getting diabetes, based on the medical data of the patients, predicting the number of customers, news classification. Actually, that's one of the examples I worked before. Yeah, so we've got a huge data sets of news, and news actually belong to different categories. Yeah, so we have news about politics, we have news about sports, we have news about like, I don't know, coronavirus, health, whatever. Yeah. So once the computer learns, then you supply the new text, and then it should actually categorize the new text of the news into the right categories. I have achieved like a score of 94% accuracy and so on. Fraudulent transaction, a lot of them actually has got a kind of, all of them has got a certain patterns. Yeah, a spam detection. So the spam emails actually have got certain patterns in their body, in which the email service providers, Gmail, Yahoo, all these services, they try to improve, their fraud detection, by identifying the patterns of the emails that are spam. Yeah. Lots of examples actually in data science exist in two websites, and you see that a lot of the references I have put are either from the website called towardsdatascience.com or another website which is medium.com. This one actually is about using machine learning to predict Kickstarter success, which I may open it, show it to you quickly, in the Q&A session. But when people actually post their innovative ideas and they ask for the public fund, people actually have collected a lot of data about different characteristics of the project. And then the thing is that, can we actually predict that, if somebody creates a new campaign for the Kickstarter, if it is going to be successful or not. So that's another example that we can see. So now, quickly, I can move to another topic which actually has revolutionized the concept of artificial intelligence. And the reason that we all, sometimes, we're scared about the future, oh my God, what's going to happen with the artificial intelligence and so on, is because of deep learning. Yeah, and deep learning means, again, it's a kind of machine learning technique. It's not simple, linear regression model that you just create a line to describe, to best represent the data. Yeah, it's a much more complicated machine learning technique. Yeah, that teaches a computer to filter inputs, and what we mean by input, again, is the data that we supply to the computer, yeah, to learn how to predict and classify information. And again, it's happening by creating a neural network. Yeah. So what you see here on the left hand side is a very, very simple neural network. Why it's simple? Because it's just got one hidden layer here. Okay. So input layer, I'll clarify this further in the future slides. But again, the images that we provide, again, they are in the pixels of data. Yeah. So if we have a simple image, black and white, I don't know, 28 by 28 pixels, so 28 times 28, that's 756. So that means 756 points of data for a single small black and white image. So that means that we're creating a neural network with 756 nodes. Yeah, so we're creating different layers. And what happens is that, if we are creating multiple layers, first we create the first layer, yeah, and then we apply the function to that layer, yeah, a model, a formula or whatever, yeah. The computer makes the calculation and then apply the output from the hidden layer is then fed into the next layer. And this process just, goes on and on until, we get the output that we like. Okay. So what does that mean exactly? Again, this is another popular example that anybody who learns in the university about, image classification, the idea is that, these numbers that we see here, regardless of how we write them, so people have got different handwriting styles, yeah, the computer should be able to classify them correctly. So no matter how we write number 0 here, then it shouldn't really matter, yeah, or how we write number 1, even if you write number 1 like that, yeah, it shouldn't really matter, yeah. If we create a good, network training, yeah, and we also define the labels, again, kind of supervised learning. So this is number 7, yeah, and number 7, if it is presented as a 28 by 28 pixels, so this is what computer sees, yeah, these are the numbers, yeah, that means 7, yeah. So I'm just explaining the concept, the algorithm behind it. What happens here, for example, if we have, you see this one in the middle, it's a 3 by 3 matrix, yeah, generated randomly. And what happens is that this filter is applied to the pixels of the image, yeah. And what we see here is the dot product of the matrix. So this time multiplied by the first 3 by 3, and the result is stored here. And then we carry on 1 by 1, yeah. We do the multiplication. So this is the first layer, yeah, that we get. Each number here represents color, yeah. The next slide actually would clarify it better, yeah. We just carry on until it identifies the edges of the image, yeah. So it identifies something like this, the one on the right, which is similar to the one on the left, yeah. So in reality, actually, it's something like it's a very simple one. So this filter here, filter 1, the top row, the 3 minus 1, that means black color. This 1 1 1 means white, and this 0 0 0 means gray. Okay, we can also present it like that. Yeah, vertically, again, change the position. So this time is gray, white, black, and so on. Yeah. So so we come back here. So this time the filter is, we multiply it, pixel by pixel, and then the technique is called the striding. Yeah, you just go one cell, do the multiplication, and we just keep doing it. And then we realize that the edges of the picture is identical. So if we use this filter, we get something like that. If we use this filter, we get something like this. It's different than this one, but again, it's close. Yeah. So this one and this one. Yeah. So that's how computer learns that what is what. So it learns that this is number 7. Yeah. So it doesn't actually have to capture exactly all this picture. Yeah. So sometimes if you have an image of a person, as long as it catches like the eye and nose of somebody, maybe that's enough. Yeah, to identify who that person is. Yeah. So that's the algorithm behind it. The technique is called convolutional neural networks, and I have actually grabbed the photos and everything, from this YouTube video. So that was also another example. Now we are actually moving to another example. So now we have learned about deep learning, yeah, and we could actually see that here that the data that we supply is a matrix here, or it could be an array, yeah. So any data that could be supplied like this, we can do the deep learning. Yeah, so it shouldn't have to be the images. It could be text and keywords. Yeah, so can keywords also convert it to a vector? Yes. How? Again, that's beyond the scope of this presentation, but I can accept it from me that yeah, we can. Yeah, the word apple actually has been converted to a vector. It's a number. Yeah. Is as a vector or array or whatever. Yeah. So once we do that, then we can do a lot of things. We can do the keyword similarity. Yeah. So you have seen that you put the keyword in Amazon website. I don't know. You buy leather shoes. Yeah. Then it recommends the similar products based on what you search. How? Based on the keyword similarity algorithms. Sentiment analysis, yeah, that's another application of the natural language processing. We can do the sentiment analysis in marketing. So the comments that people have posted online, yeah, we can grab them. I just showed you how I grab data from BBC, or I can easily also do that from other websites. And then we can start doing the sentiment analysis. In sentiment analysis, what is important for us is the adjectives in the sentences, because that's how our feelings are expressed. Yeah, so we can get rid of other parts of the sentence and just focus on the adjectives, for example. Yeah, spam detection, or as I showed you, Siri and Alexa, they are actually nice examples of natural language processing. These are voice-driven interfaces. So you speak, your voice is turned into the text, and then depending on what you said, then an action will take place. Even for financial trading, yeah. So the decisions on how to trade also depends on the news, yeah. So and I have seen that those people who are really addicted to trading, they just keep reading and keep watching the news. So if you have a very nice mechanism of summarizing the news, that would be then for example the BBC example that I showed you would come handy for you. Text prediction is another example, which we have seen that Gmail is doing it for us. When you type a sentence, it predicts what you're going to say. How? Well, quite easy. they have tons of our emails anyway. So it's a text. And they have actually they have calculated the probability of certain words when we are writing a sentence. So when you, at the beginning of your email, you say that like, hello, Andrew, I hope this email. So once you write this sentence, I hope this email, probably you're going to say that I hope this email finds you well. Yeah. Why? Because based on the training data that we have provided to Gmail, they know that, they have calculated the probability that most likely you're going to say, I hope this email finds you well. That's how you want to complete your sentence. Spell check and grammar, yeah, again, that's another application. And document similarity, which is, a very straightforward thing. And, we have also seen that, all these examples have already turned into products. And, businesses are continuing to use these concepts in order to, develop more and more products. Like at the university, we have Turnitin software, which compares the similarity of the student assignments. If they have done a plagiarism and they are quite unlucky, then we catch them, using the software. So, how words are presented as matrices, a variety of ways. But I mean, the simplest example I can show you, this is one of them. So if we have 3 sentences like this, yeah, I enjoy flying, I like NLP, I like deep learning, yeah, we can actually present it as a matrix like this, yeah. So the matrix like this. So I like, join, deep learning, NLP, flying. So these are the words that are used, yeah. So how many times the word I and I together repeated? 0. We don't find such a thing. But the word I and like together 2 times. So one is this one, another one is this one. Yeah, so 2. I enjoy, I and enjoy. Yeah, 1. Yeah, and so on. We can complete the matrix like this. Yeah. So this is one of the, again, it's not a pretty accurate way. Well, I mean, this is one of the ways of turning words and sentences as the matrix. And once you have data like this, the rest is for the deep learning algorithms and so on. Yeah, so that's how texts are converted as the vectors. Yeah, there are some other models. I'm just naming them. Again, it's beyond the scope of the lecture. But if somebody is interested in the future, I don't know, somebody watch this lecture in the future and they want to search for it, it's a continuous bag of words, skipgrams, and the term frequency. One of the most advanced libraries and methods for natural language processing is the one developed by Facebook, yeah, for obtaining vector representation of words. Almost, as I said, every word is a kind of vector, yeah. And the thing is that, one of the applications, as I mentioned here, is the keyword similarity, yeah. You watch something on Netflix, I don't know, Wolf of Wall Street. Actually, that is a vector, okay. So if you like it, yeah, or if you have searched for it, or you're asking Netflix to show you similar movies, yeah, to this one, then what's the math behind it? Yeah, would be something like this. So imagine that this is a vector. Again, that's a very simple example because in reality, it's not just a 2-dimensional vector. So it's like a vector trained in a 100 dimension, but I mean, we can't present it visually. But anyway, so imagine that, for the sake of example, this is, I don't know, the keyword called marketing, yeah? And we expect that the, marketing and advertising, are similar, yeah? So this is the vector that represents marketing, for example, and this is the vector that represents advertising, yeah? So these vectors, again, they have been trained in a way that, marketing and advertising, they are actually positioned close to each other, yeah? And the way to calculate it is that, the algorithm behind it is that it searches for the nearest points. And again, thanks to, I need to recall you of our lovely mathematical learning in high school, the idea of cosine distance or cosine similarity. So when 2 vectors, but if you want to measure the similarity, one of the ways is to measure the angle between them and take the cosine of that. Yeah. So if two vectors are identical, so are exactly the same, yeah, then their angle is 0 and the cosine of 0 is 1. Yeah. So the closer the closer the number to 1, so that's cosine similarity, sorry, not cosine distance. Yeah. So the cosine of 0 is 1. Yeah. So we can actually say that these two vectors have a similarity of 1, and cosine distance actually is 1 minus cosine similarity. So the similarity is 1, the distance is 0. It doesn't matter which one you use. Yeah. So for example, I don't know, maybe the word marketing and advertising has got a cosine similarity of like 0.85. Yeah, which means that they are similar. So we have a huge data set actually has got a lot of these points, yeah, represented in not in a 2D dimension, but I mean, yeah, if they are represented in a 2D dimension. Yeah. What happens is that when you ask for like 10 closest movies to like Wolf of Wall Street, yeah, something like that, then it searches, within the radius of the point, and it finds you, the relevant keywords for that. Yeah. So that's the algorithm. It's not exactly what's happening, but it's a kind of idea that what's happening in the keyword similarity. So one of the things that I did personally in one of my projects was that I worked with a company in London that they had a data set of 1 million companies, and each company actually was identified by a set of keywords. So company A, for example, was identified by certain keywords. So if it was a marketing company, it was defined by like 5 keywords, like marketing, digital marketing, social media marketing, all these things. Yeah. And the task actually was that I had to, I had to find a way to identify, the similar companies, and do it as accurately as possible, so searching actually in the space, yeah, and find like the 10 closest companies to like company A, yeah, out of a data set of 1 million companies. And that's how, I applied the concept of, cosine distance, but, the first thing is that if you're working with such a data set, then, it would be converting those keywords into the numbers. So that's, that's, one of the things that, that we can do. So I'm actually, getting to the end of the presentation. But before that, for example, I can quickly show, very simple data sets. So for example, if I share my desktop with you again, and then, so I'm here, and then where is it? So this one. Okay. Oh yeah, that one actually. Yeah. So if we have a data set like this, so I have actually grabbed this data. That's a public data anyway, so it's kind of free to use. I still haven't used it. Yeah. But that's actually the data similar to that project that I was explaining. So this is the data set of a company. Somebody has done a web scraping, and we've got the website of the company name, the text in the homepage. These these are the missing value, and that's normal if we are dealing with the missing value in the data. Meta keywords, yeah. So I'm actually interested in this column, yeah. So you can see that there are different companies, and all of them are categorized in these categories, yes, commercial services, supplies, healthcare, materials, and so on. Yeah. If I just grab the marketing companies, yeah, so that would be actually this one. Yeah, it's this one is just for the prototyping. So if I do this, yeah, there's 1,900 companies that are in marketing. Yeah. So if I just grab like a couple of them, so this company number 34,834. Yeah. These are the keywords, yeah, for identifying this company. Yeah. And this is the keyword for another one. But as I said, how many companies do we have? 1,900. Yeah. So one of the interesting tasks would be to, despite the fact that they all belong to marketing industry, but I want to actually find like the 10 closest companies to this one, or 100 closest companies to this one. Yeah. And this is something that, we can do. Yeah. So yeah, again, a lot of things, could be done. And my approach, if I want to, solve this problem, I would start by converting these keywords into the vectors. So I would add a new column, but after I train them into the vectors, and then I'll carry on with the relevant techniques. So yeah, so at the end, anybody who would like to actually find data for any data science project, for training, for anything, yeah, there are lots of data sets. Kaggle is number one. You may have heard it before. So you can actually find lots of data sets. There are actually so many data sets at the moment with regard to the coronavirus. If I just search like I don't know, COVID-19 global forecasting, and lots of things. There are some competitions. Some of them actually are the competitions that are created by the companies, and they actually pay you if you resolve their complex challenges. But lots of data sets already with regard to coronavirus, for example. Yeah, somebody maybe needs to analyze the tweets or everything, so on. Yeah. So yeah, you can find data like that. That would be one of the best places to look at. The other one is data.word. This one, Yelp. Yelp also, a lot of people in academia actually have used data from Yelp and published a lot of papers. Yeah. So these are only a few examples. Yeah, that's if we want, we can grab data. And the good thing about like Kaggle is that you can also check the license, and again a lot of them are free to use, as long as you just acknowledge the source of the data. So summary, well, I don't know if I went over the time or not, but demand for data science is growing anyway. Hence the competition also to enter the job is also increasing at the same time. The industry actually is finding its way on what is data science. Yeah. Again, it's become a very popular word, for people. Yeah. Some companies still don't know what that is, yeah, or they may have very strange expectations, like predict the price of Bitcoin for me, something like that. I mean, personally, I haven't worked with the financial data. I have even seen that deep learning has been used in predicting the stock market, for example. How good it is, I don't know. I would try it myself once, see how it works. But the tricky thing about the stock market is that the prediction model is not just based on the historical data. Yeah, so it's not just only a time series model. Lots of other factors contribute, which makes it very hard to predict the financial market. But I have seen that people doing quite well using the data science techniques in the financial market. So there are tons of free and public data anyway. I just showed you, how to scrape data from BBC, but again, you may be blocked. Yeah, if depends on how well the website is designed. Yeah, if you send too many requests, you may be blocked. Yeah, so you need to check the terms and condition, yeah, before using any data. Yeah, so the grabbing data, despite the fact that a lot of them are free to use, but always we need to do it in the ethical way. Yeah. And check the terms and condition. Anybody who wants to become a data scientist or work in this area, I believe that you already have got the kind of idea that what we need. Need to learn Python or R. Again, I'm a person who didn't know a single bit of coding 2 years ago. So I learned Python. Which is widely used in the industry. SQL, as I said, this is again very easy. That's for making queries from the data sets. There are actually even better ways of doing it. Anyway, that's beyond the scope of this presentation, like NoSQL, or PostgreSQL. Anyway, mathematics. Yeah, we need to brush up our skills in mathematics. There are things that we have forgotten. I almost forgot the concept of cosine similarity and cosine distance until I had to use it. Brush up your skills in statistics. Yeah, and there are lots of free sources to learn. Yeah, YouTube and lots of places to learn about these things. Udemy, if somebody needs to pay, for example, but you don't want to pay much. Udemy is great. There's so many great courses in data science that maybe cost you like £10 or so, which you can actually purchase very, very good courses in data science. Anyway, yeah, for sake of ending the presentation, these are the references I use for that. So yeah, so that's it. Well, thank you very much for listening to my presentation, and I believe that I need to stop sharing my screen.
Well, that's great. Thank you very much indeed, Nazir. It's mind-boggling. The kind of things you just described are mind-boggling. I'm actually going to unmute everybody on the call, and I will also make sure that you can join again by video if you want. So you just activate the thing on the left-hand screen. We can now all be visible. I can those, but Nazir, thank you very much indeed, because I think it's been very helpful to actually go through this. The scale of data is just mind-boggling. Now, once you've actually looked at all the nodes and all the connections and how data is actually derived, I think it's a fascinating subject. So thank you very much for bringing that to our attention. There's a few of you who are not actually on video yet. I'm trying to sort of activate the video for you, because I think otherwise you won't be able to really ask a question. But maybe somebody who's already got their video on would like to ask the first question. If you want to raise your hand. Oh, nobody. You stunned them to silence. Oh, there's John Higgins. John Higgins has got a question for you, Nazir.
Yeah.
Yeah, thank you, Nazir. Where do you think most data scientists are being employed these days? Or, what variety of places rather than most? What jobs are they getting?
Yeah, well, any industry that actually has felt the need, to use data, is using data scientists. So I have seen in the area of marketing is widely used. Yeah. I've seen that in digital marketing, that example that I showed you, actually, yeah, that was a similar example that I showed you. So I mentioned that I worked with a company in London, and the kind of, project I had with them, they were actually in the business intelligence service. So they had a software, that they were selling to clients. It was actually working based on the kind of idea that you're providing information about companies to other companies based on a huge data sets that you have. In medical sciences used quite a lot. We even have heard that these days that artificial intelligence, for example, is might help us, to understand coronavirus. Is that true? I would say yes, because as long as you have the data on how the virus behaves, and you train the computer, then it is actually possible, to predict the behavior of how the virus reacts. But personally, since my background is not in medical science, I cannot actually comment about it further. But it would actually take time, for to have a large amount of data set, for something like coronavirus. But we can see that tons of data are being generated every day. I just showed you an example. In the software developments, it's being widely used because a lot of these ideas are actually turned into the software products. For example, there was one website, actually, somebody introduced me a while ago. I think it was called JobScan website. The idea was that you would supply the job description to the website and also supply your CV, and then it would tell you that the similarity between your CV and the job description, and then advising you how to improve your CV. The way I look at it is, I know how it works. It's actually grabbing certain keywords that implies skills in the job description, and then trying to find those keywords that implies skills in your CV, and then compare it that whether it is similar or not. And they were charging, I don't know, like monthly price of like $20 or something like that, and then that's how they make money. Or any industry that creates a structured data set. That example, very simple example that I showed you about, like grabbing the news. We have lots of data sets about the archives of news, from different sources. All they have done is that they have grabbed the data from different points and make them in a very structured way, presented them in a very nice way as a product, as a software, and charge people.
Thank you.
So I would say a lot of industries.
Good. Oh, Ian has got a question. Ian, over to you.
Yes, thank you, Nasser. I have a question relating to the Facebook company, which you may remember about 2 years ago was getting a lot of probably rather unwelcome attention about the seemingly illegitimate use of its data that it was providing to other companies, which were then selling it on. This sparked a little controversy between me and my friends. Some of my friends said, well, Mark Zuckerberg, when he set it up, claimed that he did it just for fun, and that the data he was gaining, he was able to monetize in the means which then got exposed a couple of years ago. My contention, however, is that he set it up from the very outset, recognizing even 15 years ago that data was going to be enormously valuable. Therefore, he would try and find a way to harvest enormous amounts of data, which he could then monetize by selling it to other people. So my question to you really is, which side of that fence do you fall? Do you think he was set out from the very beginning to harvest data in a way that looked perfectly harmless to most of Facebook users? Or do you think he accidentally found a way to monetize what he'd got, and therefore thereby made his fortune?
Well, it's a very interesting question. To be honest, I'm not in his mind, to to really know that what was his intention was. But most likely, he knew what he was doing anyway. He's a genius, and he definitely realized about the, maybe at the beginning, when he was a student, he didn't have any idea that what Facebook might become. But as Facebook grew, then obviously the company realized that they've got very valuable information, of people's data, in which they can monetize, and they have actually monetized it in both legitimate and illegitimate way. Legitimate way in the way that, if you have a business and you want to promote it via Facebook, then yeah, it's very clear that how you need to do it. You go to the advertising section of the Facebook, and based on your geographical area that you want to target, that you want to promote your business, you pay certain amount of money, to Facebook, that if somebody clicked on your advert, or if they purchase your products through clicking on your Facebook campaign, so that's a very obvious way on how Facebook, for example, is making money. There is also, illegal way of making money, and a lot of people know about Cambridge Analytica, that they hacked Facebook. If you know more detail, those people who have watched the documentary on Netflix called The Great Hack, if you have watched it, I think after watching it, you want to delete your Facebook page if you have one. Yeah, but I would actually say that even if you delete it, it's not going to change anything. You're just going to delete your Facebook account for your friends. Otherwise, the data, I think, will still be there. Yeah, the Facebook was hacked by a company called Cambridge Analytica. A professor in, I think, Cambridge University, if I'm not mistaken. He designed a questionnaire, to test someone's personality, something like that. That questionnaire actually was a trap. Yeah. So some people, he posted that questionnaire on Facebook, and people clicked on it in order to fill out the questionnaire. But actually, everybody who clicked on that, they were hacked. Not only they were hacked, but also their friends were hacked. Yeah. So they could actually grab the personal data of like 10 million people on Facebook in the UK and in America and other places. I mean, that documentary, explains it clearly. And then, because the example I showed you, that how I grab data from BBC, I can't do it on Facebook. Yeah, it's going to be very strict. Yeah, even on Twitter, Twitter allows people to grab hashtags. Yeah, that's permissible. You can grab the text of the hashtags, but you can't actually, extract data easily. So it's not actually easy to grab data from Facebook in such a nice structured way that I did for BBC. But those people could do it, and they had tons of data about people's behavior. The things that they liked, the posts, the private messages, lots of data in form of text, image, everything. And then they employed the best people, the best psychologists to as well as the best data scientists, to do the consumer profiling. So what kind of person you are based on your profile, the Facebook profile. Yeah. So and everything that you posted, or the things that you liked, all these things. So then they started to filter out people who they thought that would be the potential supporter of Donald Trump, for example. Yeah? And then they started to target these people by using the paid advertising on Facebook. Mark Zuckerberg knew about it. He knew that the Facebook was hacked, but since they were spending like millions per day, for the Facebook advertising, he was happy actually for this to be happening. So. Yeah, and we know the story. We know the rest of the story and the scandal by Cambridge Analytica. This is actually one of the examples of unethical use of data science.
Yeah,
in practice.
Absolutely. But I'm glad when you started the response to the last question. I'm glad you're not in Mark Zuckerberg's head. That's good to know. And for those of you who want to get into Mark Zuckerberg's head, I suppose the closest we're all going to get is by watching the film called The Social Network.
Oh, yeah.
And that's probably the closest we're ever going to find what makes Mark Zuckerberg tick. But let's move swiftly on. Is there anybody else with a question? It says Vicky Davis, but this is Mr. Davis.
Yes.
Hi, it's actually Tony Davis. Do you think it's possible for an individual to protect themselves against the unethical use of big data
No.
Or alternatively, is it possible for the system as a whole to protect users against unethical use?
Well, my honest answer is no. Yeah, as long as we have technology, we have laptops, yeah, and we are actually generating data, we can't actually we can't actually verify that what's happening in our data. Yeah, despite the fact that the GDPR tells you that you can question the companies that what are you doing with my data. Yeah, you can email them, you can even ask them to delete your data, yeah, if you want. Whether they do it or not, we don't know. Yeah, you can contact the company and say that please delete any data that you have, and they say yeah, absolutely, we do it. Bye. Yeah, but the best thing to verify is that you go there, yeah, and then see that if they have really done it. Yeah. And the other thing is that the computers that we use, the mobile phones that we have, they all have the terms and conditions, long terms and conditions. Nobody reads that, but a lot of them actually gets your consent that they're going to use your data. Otherwise, you're not allowed to use the software. You're not able to install the software. Yeah. So that means that nobody's supplying the data, and yeah, I think that there's no way for us to stop it, because we give our consent when we use the technology for these companies to use our data. If we don't want this to happen, we shouldn't use the technology, which is again not possible in this century.
But I suppose what you're saying is that the sort of basic assumption must be everything we do online is somewhere in the technological biosphere. And we need to understand that that data will be somewhere, maybe analyzed in different ways. Anyway, anybody else for any more? It is coming up to 5 minutes to 9. Vicky, this time.
So yes, I'm really thinking about all the government announcements about COVID-19 and how they say they're working to the science. They also I presume means they're working through a lot of the scientists are analysing a lot of big data that's being generated recently about COVID-19. So am I right in assuming that when they say they can't compare, for example, the death rates of COVID-19 across Europe and across the world, etc., that is because there are these huge data sets, but at the moment it just takes a sheer amount of time and knowledge to try and clean these data sets so they are comparable. So I don't know if this is possible from your experience, is how long do you think it's going to take for, as it were, the computers and the scientists to clean the data sets to try and get some comparable data from very new data sets?
Well, I would say that the problem actually is not cleaning the data sets. Yeah, that actually could be done quickly. The problem would be building the models in order to predict the virus behavior.
Okay. Yes.
So because we may not actually get the accuracy, especially if we are developing a vaccine, the accuracy that we get should be really high. Even like 5% chance of going wrong in medical science would be considered too much. Yeah. So I would actually say that the problem is not necessarily cleaning the data. It's about actually coming up with a proper artificial intelligence model that can understand the behavior of the virus. And the other thing is that, if we are lucky enough that the virus does not mutate in a way that whatever we have done, to understand it again, it changes the behavior once we, develop the vaccine. Hopefully it doesn't happen in this way. Yeah. But one of the reasons that they say that, they may never find a vaccine is because of this. It might be because of this. Yeah. Okay. Otherwise, technically speaking, it should work. Hopefully, I don't know. Well, we can. Well, we all have to live with hope, So, and that's what I'm hoping for.
Okay.
Thank you.
Thank you. We have time for one last question. Anybody? Okay. No more questions. Oh no, Val Mason.
Hello.
Hello.
I just wondered if you could give us any others besides Facebook, which you would recommend that we don't open on our from your knowledge of them.
I don't know. I mean, every company, you know, every company holds
Careful
data.
what you say, Nazir. Now the corporate lawyers are already waiting.
Everything, you know, well, every company can be hacked, I can tell you. Yeah, so this is the best answer I can give. Yeah, every company can be hacked. Yahoo actually was hacked. I can tell you that if you are, well, not only from my own perspective, but I've got a very good friend who is, you know, one of the best, you know, in the network security, and I always follow his advice. He's always telling me not to use Yahoo Mail at all because the security level is very bad, and Gmail actually is a lot better compared to that. So based on also in terms of, you know, security of, like, if you're creating an email, I haven't actually heard really you know, positive things about Yahoo, for example. Yeah, I hope they don't sue me after that.
Okay, thank you.
Good. Well, on that basis, we're going to draw tonight to a conclusion, but I would like you to all join me, please, to thank Nazir in the usual way.
Oh, thank you very much.
Good. I think, you know, I've been actually quite impressed with tonight. The technology didn't let us down. We're doing this at 7:30 at night when America is all online, and we didn't have any technological problems. So very, very good. One of the things that I would appreciate if you all wouldn't mind just sending me an email to let me know whether you like this kind of live lecture, whether we should do more of these, or whether you think it's a bit overkill. But obviously, given that we're still within the corona virus situation, we are very unlikely at the Brilsey to have live talks back again until at least September, if not later. So if you like it, I know the thumbs up, that's great. But if you could drop me an email, that would be great as well, to let me know what you think. And then we'll schedule the next live meeting as soon as we can. Next week is not going to be a live call. It's going to be an audio only, where I'm interviewing Chris Martin about monetary policy and central banks' response to the crisis. So it's an audio only one, but maybe the week after we can return back to live lectures. So I wish you a very good evening, and Nazir, once again, many, many thanks to you for an excellent lecture, and all of you will find this online in the not too distant future. So thank you very much for participating, and I shall see you next time.
Thank you, Andreas.
Thank you very much.
Andrew.
Bye-bye.
Bye.
Bye.